Okay, I'm going to start the webinar. Okay, good morning everyone and welcome to today's webinar. My name is Kabir and I'm with Bad Liver Research Group. I will be your host for today's session. Today we have an amazing speaker and he will be talking about protozoal diseases in cattle. Before we get started, I'd like to take a moment to thank all the counties that support and fund us. Because of their funding, we are able to do webinars and workshops, which are valuable and valuable to our producers. Just a quick couple housekeeping items. If you have any questions during the presentation, please hold them until the very end of the session. We will have a short Q&A. If something urgent comes up or you need my help during the webinar, feel free to drop a message in the chat. I will be keeping an eye on it throughout the session. It's my pleasure to introduce Dr. John Campbell. He's a professor at University of Saskatchewan and a graduate of Ontario Veterinary College. He spent more than 30 years at Western College of Veterinary Medicine, where he focused on beef cattle production medicine, disease surveillance, and directed the disease investigation unit for 2 decades. Over to you, Dr. John. We can't hear you. Your mic is off. Dr. John, your mic is off. Can you hear us, Dr. John?
Yes, I can hear you. Sorry
Oh yeah.
about that.
Yeah, your mic was off in the beginning.
Yeah,
Yeah.
no worries. Thank you, Kabir, and thanks to the Battle River Research Group for having me. It's a real honor to be here, and just to let you know that the Professor Emeritus thing just doesn't mean much other than I've retired. So I'm no longer teaching at the vet college regularly, and I'm happy to take this on today with you guys. So thanks for having me. I'm going to talk about some protozoal diseases of cattle, and I want to start by talking about what protozoal parasites are and what we know about them, and then I'm going to try to cover four major diseases, which is a lot to cover in 1 hour, but uh, we'll go through coccidiosis, cryptosporidiosis, trichomoniasis, and Neospora abortions, which are all protozoal diseases. And then briefly at the end, I want to talk about a new protozoal disease that we're seeing in North America that might come our way someday, but may or may not. We can't really tell for sure, but it's a very interesting one. So let's start by talking about protozoa because they're kind of unique little creatures. They're single-celled organisms. If you think about the amoeba you used to see in school when you looked at pond water or something like that, those are protozoan organisms, and so they have no rigid cell wall. They're flexible. They have varied shapes. They're microscopic. We only can see them through a light microscope. They usually possess some ability to move, not always, but most of them do. They consume nutrients, and some have forms that can form spores as part of their life cycle, so they can survive in the environment for longer periods of time. The parasite part of them is any organism that lives on another living being or the host and survives by feeding off it at the host's expense. We all sort of know what parasites are. We think of often worms or external parasites like lice, but there's a number of protozoa that are significant parasites of cattle that we're going to cover today. And like many of the parasites, they can have pretty complicated life cycles, and we're not going to go into tons of detail on those life cycles, but it is important sometimes to understand a little bit about that. They can be spread by a variety of means, direct contact, contaminated food and water, insect bites. We're gonna cover that when we talk about the diseases. So we got four parasites that I think are of significance in Canada. We have these intestinal protozoan parasites that cause diarrhea in calves. So most of us know about coccidiosis. The technical Latin name for that bug is Eimeria. Cryptosporidiosis is a little less well known, but very similar to coccidiosis, maybe a little more severe. Um, Trichomoniasis, probably many of you have heard of that, or trick, that is a reproductive tract parasite, and then an abortion-causing parasite, Neospora. In many parts of the world, the probably more important diseases are blood parasites. And so malaria is a good example of a blood parasite. But in cattle, we have anaplasmosis, which sometimes makes its way into Canada now and then. And then this new parasitic protozoa called Theileria or theileriosis is the disease that we're seeing emerge in the US right now, and may be spreading its way west. So let's start with coccidiosis. It's probably the one most of us are familiar with. It's an old disease. In some ways, it's one of the most aggravating diseases to deal with as a veterinarian or a producer, and can be pretty significant economically in the cow-calf industry and the feedlot industry to some extent. One of the reasons it's so important is it's so widespread. Almost all cattle are exposed. Many sheep, goats, other species are exposed as well, but it's a species-specific pathogen. So there are coccidia that are only for cattle, and there are coccidia that are only for sheep, and there are coccidia that are only for goats, and there are coccidia that are only for chickens or pigs. So, you know, they all have coccidial parasites, but they sort of stay within their own species. The other thing that's interesting about this disease is that lots of the infections are kind of mild or self-limiting or even asymptomatic. Animals can be infected and we don't see any clinical signs, but when they become overwhelming, we have overcrowding, we have poor sanitation, they get more of this parasite infecting them, they can get pretty severe clinical disease. And we see the clinical disease in two main groups, mostly in 1 to 3 month old calves, sort of greater than 21 days of age. So this is not a newborn calf diarrhea. This is a 3 week or older calf, or in calves around the time of weaning or shortly after weaning, often under a period of stress or something like that, when we're bringing them together after weaning. And it can cause, as I said, significant economic losses. I don't want you to worry about this slide at all, other than to know that there's a whole bunch of different coccidial parasites. And there's different species, obviously, for sheep and goats and cattle. But in cattle, there's at least 13 species identified, and they vary a lot in how severe a disease they cause. So the two most severe ones in cattle are Eimeria bovis and Eimeria zerniae. The names aren't important, but unfortunately, when we look at a microscope at a sample of feces, we can't tell which of these Eimeria it is. We just see these little round coccidial parasites that we can identify and we can count them, but we don't know which ones they are. And there are some species that are not pathogenic at all. They don't cause any disease or any clinical signs. So that can get difficult when we start talking about the diagnosis of this as well. It's got a really complicated life cycle, and I don't want to get into the details of it by too much. There are these oocysts, sort of the protozoan form of eggs that are in the environment, and they require some time to sporulate. And that depends on moisture and temperature conditions, a bunch of things like that. But they can survive in the environment as a spore for months under sort of moderate conditions, as long as there's some moisture. Even in the winter, if there's a bedding pack, they can survive for a long time in that bedding pack if there's adequate moisture. If they get extremely dry or a lot of sun exposure, that kind of limits their survival. So that's one of the good things about coccidia, that we can kind of limit them that way. The length of the life cycle varies a little bit. So you can see I got 2 to 4 weeks, probably averages about 3 weeks, 21 days. So that's important because we don't see disease until calves are probably at least 3 weeks of age. They get infected usually in the first few days from their mother or from other cattle, and they're not going to show disease until they're 3 to 4 weeks of age. So here's the life cycle. It's very complicated. There's all sorts of different stages it goes through and multiplies within the calf, within the intestinal tract. And at several of those stages, it breaks open the intestinal cells and migrates. And that breaking open of the cells is what causes the disease, causes diarrhea, causes malabsorption and inability to absorb nutrients, etc., and causes the disease. There is this stage on the bedding pack or on pasture where those oocysts have to sporulate and develop a little bit in the environment. But the big part of this life cycle is how quickly this pathogen or this disease, this parasite multiplies. So if you start with one oocyst, it goes to the next stage called sporozoites. Again, the names don't matter. There's 8 of those, then it goes to 120,000 times 30 of the next stage times 80% of those turn into macrogamocytes, etc. All of a sudden, you go from one oocyst to now 23 million oocysts. So this parasite has an uncanny ability to multiply at just tremendous amounts. And so we know that, 50,000 oocysts ingested by a young calf can cause severe disease. That calf is going to now be putting out hundreds of millions of oocysts into the environment to infect other calves as well. So an incredible ability to multiply. That's why it's so difficult to control and so difficult to deal with because it can multiply within these animals at such a rapid pace. Well, so if most of these animals get exposed to this, almost all cows are exposed to some specific Eimeria species, some coccidia, and once they get exposed, they will develop some immunity. And the amount of immunity they develop depends on how much they get exposed to, how good their immune system is, all sorts of different things like that. But if they develop reasonable immunity, then other infections down the road tend not to cause clinical disease. So we don't see coccidiosis in older cattle very often. It's very, very rare. It's a disease of calves or of weaned animals under stress. And but cows don't get clinical disease. However, the cows can still get oocysts, develop them, and shed them. So they're one of the sources of this parasite in the environment. Their feces is still going to contain some oocysts, small numbers. They're just not going to have clinical disease. The level of immunity is probably dependent on how many oocysts they ingest in their initial infection as a calf. So if they just get a few, they probably don't get sick. They probably get less immunity, perhaps, and so maybe they're more susceptible later on in life. If they get a lot, they might get clinically ill. They'll probably develop a little higher level of immunity. We probably want it somewhere in between where they get exposed a little bit, but not too much, so they don't get they get an immune response, but they don't get clinically sick. So the clinical signs with coccidiosis, it's like this is the one where the dose is equal to the severity, that how many oocysts they get exposed to, how much feces they're exposed to with infective oocysts, that's going to determine how severe the disease is. And as those coccidia replicate within the intestinal cells and rupture those cells, if they get very light infections, the calf is healthy and has good colostrum and other things, they can repair the damage quickly and develop some immunity. But if they get heavy infections, they get really severe damage to the intestine and they can lose blood and fluid and electrolytes, causing this significant diarrhea, often with blood in it. So that's what we see. We see diarrhea as the primary sign. These calves often strain because this diarrhea tends to affect the larger intestine and the lower intestinal tract. The blood that we see in the feces is variable. Sometimes it looks really dark and tarry. Sometimes it's streaks of fresh, bright red blood. Sometimes it's great large clots of blood. So we can see all of these depending on the level of the intestinal tract that's affected. And that depends a little bit on the species of coccidia that infects the calf. If it's a severe infection, they can become pretty anemic. They lose blood, and so that's a pretty common issue and can actually cause the death of the calf. They'll sometimes have a bit of a fever, They don't get as severely dehydrated as we see with other forms of calf scours, but they can have mild to moderate dehydration, and it really sets them back. The course of disease is maybe only 5 to 6 days. They usually get better on their own, so it's usually kind of self-limiting, but some calves can have severe intestinal tract damage and really set them back for a long time and have a difficult time sort of recovering back to sort of normal productivity. And of course, really severe infections can kill calves as well, and that's usually because they're losing so much blood and other fluids and electrolytes. So it's a relatively low mortality disease, but there's often a lot of calves with some level of disease. Treatment's really difficult. It's time consuming. Many of the mild cases have significant weight loss, and some of those moderate and mild cases will take some time to recover and get back to normal. And then some of these severe cases die from this anemia and blood loss and dehydration. So it's important to know the epidemiology here. The cows are walking around, they don't get clinical coccidiosis, but they have coccidia parasites in their feces. And so, like all the scours diseases, reducing the exposure of the calf to adult feces or to other calves with diarrhea caused by coccidiosis is the really important way of reducing their infection rate. There's a bunch of other factors though, and this is the classic triangle of the host or the cow, calf, the disease agent, in this case coccidia, and the environment. So the animal, the host, we worry about their immune status. Did they get good colostrum? Are they under stress? So all those sort of things that happen around weaning time, diet changes, weaning, shipping, crowding, those can contribute to it. Are they susceptible? Do they have any immunity? Have they been exposed before? Age group, we've talked about that a bunch already. From the disease agent, it's mostly a numbers game, right? How many are they being exposed to? How much contamination are they receiving? The species matters a bit. Some of the species are more disease causing than others. And then how widely dispersed is that coccidial parasite? Is it in all the cattle, or a bunch of the calves are infected, or just a handful of them? And then finally, the environment, that's going to affect how quickly it sporulates. The management system, if we're crowding these animals together, that's more likely to cause problems. The hygiene, so how much feces they're exposed to and whether the feed and water is contaminated as well, can make a difference. So we need a warm, moist environment, and that's possible even with freezing temperatures. So there's a bedding pack. We see lots of coccidiosis outbreaks in very, very cold weather. Doesn't limit them very much there. Obviously, spreading animals out's the best option, and we see this disease more commonly in dairy calves and feedlot calves where animal populations are concentrated. But even in cow-calf situations on pasture or at calving time in paddocks, animals don't always spread out, even at pasture, right? We concentrate them around water sources, we concentrate them around food sources, around maybe shelter, things like that. And so we can have concentrated areas where they're exposed to a lot of feces fairly quickly. As I said before, the diagnosis is a bit complicated. Really, the only thing we can do is do this fecal sample and count the oocysts. But as I said, there's all these different species of Eimeria, and only two of them are really pathogenic, causing severe disease. So we get lots of false positives where you say, oh, I can count all those oocysts, but maybe I don't have severe clinical coccidiosis. And then in some cases, you can get pretty severe disease in the early cycle stages of this disease before they start shedding a lot of oocysts. So you could count them and say, oh, I don't see very many oocysts, but this calf looks like it has coccidiosis. Uh, it's a fairly easy disease to diagnose from clinical signs. We know what it looks like. We see the signs of anemia. If the blood loss is significant, they're straining, they have diarrhea with blood in it. Most of us recognize that disease. But the egg count or the oocyst count on feces is probably the easiest way to get an idea of how much exposure they've had. We can also diagnose it at postmortem if we do have mortalities. I want to talk a little bit about nervous coccidiosis, and this is a bit of a conundrum. We don't completely understand it. It's a neurological disease that we see in cattle, usually feedlot cattle or older calves, 6 months of age or so, sometimes a little bit younger. And it's been associated with coccidia infections, but we don't completely understand it. We think there's a specific toxin that gets released and affects the brain. It seems to happen when we get cold weather. Don't know why that happens. And you'll see these calves, they're really dramatic. I've got a couple of videos to show you here in a minute. They all of a sudden become very uncoordinated. They start twitching, they lose their balance, they go down and they do the funky chicken. They're doing these bicycle movements of their legs and kind of contract their spinal muscles and snap their eyelids. And then after they do that for 30 seconds, a minute, 2 minutes, whatever, they all get up and walk around and look like nothing happened. It's amazing. But eventually those seizures become more frequent and in most cases they die from this. It's very difficult to treat them. The case fatality rate's probably greater than 75%. Thankfully, we don't see it nearly as much as just regular intestinal coccidiosis. And again, we don't completely understand it. There's some work done years ago at the Western College of Veterinary Medicine where they isolated a specific toxin that they think comes from the intestinal tract that when they're infected with coccidiosis, but we don't really know all the reasons behind it. So here's a little video. You can see this calf has just gone down. I don't know. These don't look like they're 6-month-old calves, but I think they've been weaned. And this was quite a large outbreak. They weren't in a typical feedlot situation where I often see this, but you can see this animal kind of having seizures. It's down. And if you waited a few minutes, that animal would probably get up and walk around. Here's another one from that same situation. I think if we watch it, you can see it's got some staining and dark colored manure around the back ends of all these calves. They've got clinical intestinal coccidiosis as well. And there they go down and do this seizure related activity and then get right back up again. Eventually, many of these calves will die. It seems very difficult to treat. I've had some veterinarians tell me they've had some luck treating them, but I certainly haven't had a lot of luck in my career treating these calves. Um, Unfortunately, there's no, diagnosis in the brain that we can get from this. We kind of look at them and rule out other causes of neurological disease, and show that there's some coccidia in their intestines and decide that that's probably what that is nervous coccidiosis. So a very unusual one. Thankfully, we don't see that a ton, but some of you who are online may have seen that from time to time, and we do get it occasionally in outbreaks. So environmental management is key. It's the one thing that a lot of us don't want to try to do because it's complicated, trying to spread animals out, making sure that there's relatively little exposure of those young animals to oocysts and to fecal contamination, avoiding fecal contamination of food. It's the tougher one to do, but it's probably a key control mechanism. We do rely on other pharmaceutical products to try to control coccidiosis, and there's sort of two classes. There's drugs that are preventive that kind of stop or lower the shedding rate. It's not stopping infections, but it certainly lowers the shedding rate significantly. So the ionophores, most feedlot cattle are on a monensin or lacilacid, one of those ionophore type products. There's another product called decox or decoquinate that are both in feed sort of coccidiostats. They reduce the shedding of the animal and really reduce the likelihood of them getting clinical coccidiosis. And then there's a newer drug. It's not that new. It's been around for a while called toltrazurol. It's a single oral dose that can be given to calves prior to getting coccidiosis that prevents um, infection to some extent, lowers the shedding rate again, makes the clinical disease less so. And that drug is actually useful as a treatment as well. So talk a little bit more about that in a minute. The difficulty with it, it's a single oral dose that you're supposed to give ahead of time before they get clinical disease, if possible. Um, and in many cases, in Western Canada, veterinarians and producers, they're using that in beef calves at birth or at day one in calves because that's the easiest time to get those calves and give them a single oral dose. The commercial drug is called Baycox. It's an oral solution. There's also some veterinarians that get a compounded product done at a pharmacy that's like a bolus that can be given to calves. The difficulty with that is you can't sort of change the dose based on the size of the calf, etc. Toltrazerol, there's lots of clinical trials done on it, but usually in older calves, 3 weeks of age or closer to weaning time or something like that. There's no clinical trials done on those calves at birth, but it seems apparently, and from producers telling us and other veterinarians, that it works dramatically well, that it is a useful way of limiting the clinical disease with coccidiosis by giving these calves a single oral dose at or shortly after birth. Um, and that seems to work. There's just no good clinical trials that have examined it the way we tend to use it in Western Canada. One of the issues, like all parasite control products, the parasite can develop resistance to it. And they're starting to see resistance in Europe. And I know that it's being used a lot by a lot of different producers that have coccidiosis problems. We may start to see resistance develop for this drug down the road. There's a couple other treatment products. Again, all these treatment products, they help to some extent, but they're not perfect. The animal's kind of got to get over it and heal the intestinal tract on its own. Amprolium is the liquid product that we do. We also have a feed premix that I've had good luck with in some outbreaks, helping to lower the clinical uh, rate of infections in calves. And then some of the sulfa drugs can also affect the early phase of the life cycle. And again, toltrazerol can be used as a treatment again. Well, if we're trying to use a feed medication, obviously getting that into really young calves is a pretty big issue. They're not eating creep feed very much, less than 18 days of age or anything like that. So it's pretty difficult to give them ionophores or decox or anything like that. They're not going to be eating enough creep feed. There are some milk replacers that can have decox in them if you were feeding a calf or something like that, but that's obviously not going to work in most cow-calf operations, works in a dairy situation perhaps. Clorazaril is the big one. It seems pretty effective, but there's no good trial data on the way we use it in Western Canada, where we're giving it to beef calves in the first couple days of life. So environmental management's key. It's often the toughest thing to do. It gets ignored a little bit. Doesn't matter what pharmaceuticals you use if you sort of overwhelm the environment with too much exposure to this parasite. But we do have some pharmaceutical options that are reasonable for treatment and prevention, and toltrazerol seems to be the one that most efficacious. But again, we don't have a lot of good clinical trials to prove that conclusively. But from what we hear from most producers and veterinarians, it seems to make a fairly significant difference. So let's move on to cryptosporidiosis. It's very similar to coccidiosis. Again, another single cell protozoan parasite causes calf diarrhea, can also affect lambs, kids, foals, and people. So this is a parasite that is a zoonosis. It affects people as well. And every year at the vet school, when I was there, we would get some students get sick around calving time because they got exposed to a calf with cryptosporidiosis and they would get a pretty nasty diarrhea and enteritis for a few days. There's actually about 4 species of this parasite in cattle. And the only one that affects people and calves is called Cryptosporidium parvum. It's very, very contagious. There are also cryptosporidium that just affect people. And in fact, most of the outbreaks in people are caused by those. They're not caused by calves. But if you have this in your herd, you want to be careful. You want to take precautions. You want to wash your hands. You want to use gloves. You want to use things like that when you're dealing with these calves because it is a nasty disease that you don't want to get around calving time because you can't be very far from a bathroom. It can get into water supplies. It can be very difficult to control in calves. It's really difficult to treat. We don't have the treatment options like we do in coccidiosis. So that's the challenge with this one. I think it's probably a more severe clinical disease. These calves get really, really sick. They have a really nasty, nasty enteritis. And then with people, it's the very same thing. They do have a good immune response once they recover from it. But in people, it's a major problem with immunocompromised people. So if you have this disease in your calf herd, you want to keep the elderly and young kids away, etc., not to make sure they don't become exposed. The big difference, same family of organisms as coccidiosis, similar kind of disease, but it's in younger calves. So remember, coccidiosis is 3 weeks and older. This tends to be 1 to 4 weeks of age. And it looks a lot like the viral diarrheas that we're used to in cow-calf operations, rota and coronavirus diarrhea. And in fact, it often occurs in combination with those. So it makes those diseases even worse. And that's what's so challenging about this disease. It's often a combination with either E. coli or viral diarrhea problems, making them even worse. Again, it's a parasite, sits on the surface of the cells. It causes damage to the intestines, much like the viruses do. It blunts those villi of the intestine and causes a malabsorption then. They get diarrhea, they go off feed, they get severely dehydrated and have weight loss. And these calves often need IV fluids. Giving them oral fluids may not be enough because there's so much damage to their intestinal tract. They often need IV fluids. I've dealt with a few outbreaks in cow-calf herds where we had to put tons of calves on IV fluids. The producer learned to give IV fluids on their own so they didn't have to keep bringing every calf into the clinic to treat them. Um, we don't have the the anti-coccidial drugs don't work on these things. We don't really have any effective pharmaceuticals for control. There's one product in dairy cattle that they use, but you got to give it every day for 7 days. It's not very practical. It's sort of a prevention product to reduce shedding. It's not practical in the cow-calf situation. And again, the diagnosis from a fecal sample, we can identify the cryptosporidium in the feces when we do that. So again, single-celled parasite, very similar to cryptosporidium, but the big difference is the life cycle period's only 3 to 5 days. It takes no time at all for this to start, and so these calves can be quite a bit younger when they're affected, which also makes the disease worse on them. Just briefly, we had a big cryptosporidium outbreak in North Battleford way back in 2001. A whole bunch of people were hospitalized. This was probably a human cryptosporidium. It had nothing to do with cattle, but gives you an example. The wastewater treatment plants upstream of the intake for surface water treatment plant in North Battleford, which is probably not a good design idea. They had a failure in the water treatment plant and they didn't inform the health district. And one of the family doctors in town all of a sudden notices that we're selling out all the diarrhea medication in the pharmacies. Nobody can buy it. And so he starts ordering stool samples on all the patients and they identify cryptosporidium. And there's been a number of big outbreaks like that in people, usually associated with the human form of the parasite, not the cattle form, but occasionally cattle sometimes get blamed that they might be contaminating a water source as well. That's usually not the case. It's usually the human form. Again, short life cycle period. The oocysts get infective immediately. They don't have to sit around and sporulate and stuff. So you get much more rapid contamination in the environment, and it's really resistant to most disinfectants. So in a dairy situation, it's hard to disinfect the calving barn and things like that. It can survive for long periods of time in the environment again. So we trying to keep the environment as clean as possible. We don't have any vaccines. We don't have any good therapeutic products other than supportive care, giving them IV fluids and things like that. So it can be a really challenging outbreak if we get it in a cow-calf herd. Again, all the usual strategies for calf scours control, separate wintering in calving areas, colostrum, clean environments for calving cows and young calves, quarantining those scouring calves, getting them away from the other healthy calves. And probably the big one for this one is biosecurity. Don't bring other calves into your herd during calving season. If you bring cryptosporidium in, it can be a real disaster. So, cryptosporidium, very similar to coccidiosis, a little different age range, a little more difficult to treat, maybe a little more severe disease. And we're starting to see more. It used to be kind of a dairy disease. We've started to see more and more outbreaks in cow-calf herds over the last 10, 15 years. Well, I want to talk about trichomoniasis quickly, and probably most of you have heard of trich. It's this venereal disease of cattle. It's not a new disease, first described in France in 1888, and I was a new faculty member at WCVM and just a couple years in, and in 1993 we diagnosed it in Canada for the first time. We didn't think we had it in Canada. We thought it was a U.S. disease. Uh, it's usually a disease of open range beef operations. It's usually like a community pasture disease where we have a number of herds together on a single breeding field. So we found it in 1993, 94. Dr. Jansen was responsible for finding this disease at the XL community pasture in southern Saskatchewan. And after that, we started looking for it. And we found it all over the place and was in 25 other community pastures in the next couple of years. About 6% of the bulls that we sent into the lab were found to be positive. We sort of said, oh, this disease does exist in Canada. We've had it all along. We just didn't know about it. It's this very tiny parasite, a protozoan again, lives in this time in the reproductive tract of both the cow and the bull. And it has these three long whip-like flagella that help it to move around at the front of it here. And that's why the trichomonas for those three flagella, fancy name, we usually call it trich. So here's a scanning electron microscope of one up close. You can see this kind of amorphous shaped uh, amoeba-like organism that now lives in the reproductive tract and causes infertility. It's a single cell organism. It's really fragile. This one doesn't live in the environment very well, so it's different than coccidia and crypto that can sort of sporulate and live in the environment. This one can't. It's got to stay in the animal. And so the only means of transmission is by mating. It spreads venereally or by mating. So from an infected cow to a clean bull, or from an infected clean bull to a clean cow. AI, probably not very likely transmission. Occasionally can contaminate semen during collection of semen from AI studs, but they do a lot of testing to make sure AI studs don't have trich. It can be preserved in frozen semen, but the semen companies regularly test bulls, so it's very unlikely to be spread by AI. It lives in kind of the folds of the sheath and the prepuce in the bull and inhabits these kind of little crypts or crevices there. So bulls are the long-term carriers of the disease. They are usually infected for life, and older bulls, they have deeper crevices and crypts in their prepuce, and so they're more likely to carry it and more likely to remain infected for a long time. But we don't see any clinical signs of disease in an infected bull. He looks normal. His semen test's normal. He's fine. He looks okay. We just can't tell that he's infected with trich by looking at him unless we actually test him for that disease. Cows can carry the infection. They can spread it to bulls. That lives in their reproductive tract as well, in the vagina and uterus. All ages it can be susceptible. Eventually, if they are infected, they will usually conceive, they'll get pregnant. However, they'll develop an immune response. They react to the presence of the parasite. They get this mild inflammatory response in their uterus, and that causes the death of the embryo. So they lose the pregnancy very early. You don't see an abortion usually. Cow comes back into heat eventually, and you get these infertility episodes where we get low pregnancy rates. There's a bunch of cows cycling again later in the breeding season. Sometimes they get pregnant late, but they have lots of difficulty getting pregnant because they're losing the embryo because of this inflammatory response. We want to make sure cows are clean, and we know that if she calves successfully, she's almost certainly free of T. fetus. There's a slight chance she could still be infected, but it's very rare. We can't really test cows for this disease. It's hard to find it in cows. So we can know that a cow that has a calf at foot, she's probably a clean cow. She's calved. She's probably fine. So where do we see it? We see it when we get a high percentage open cows, late pregnancies. We see it on community pastures. That's by far and away the most common one, or in herds that send some of their cows to community pastures. Occasionally we see some abortions. Often there's a cow or two that has some evidence of pus in the uterus, pyometra. They've lost the pregnancy, but it's they haven't ejected the small tiny fetus that was there, and so it develops into sort of a pus-filled uterus. We don't see any clinical symptoms in the bulls. They look fine. Their semen can test normal. And there's another disease that many of us know as Vibrio or Campylobacter fetus. It's a bacterial infection. It looks exactly the same as this. So we have to consider both diseases when we see situations like this. There's no treatment for this. We don't have a good treatment. There's none that have been successful. There's no method for treating and ensuring an infection's been cleared from infected bulls. So the only solution we have is to cull infected animals of any kind, infected bulls, potentially infected cows. That's the only option. Cows will probably clear the infection eventually, but bulls won't. They're infected for life. So we got to cull them. We have a pretty slick test for this that works fairly well. It's not perfect. We usually focus on the bull because we can't really culture it from the cow very effectively. We can grow it from aborted fetuses sometimes as well. But from the bull, we just take this scraping from the sheath using an AI rod and take that and put it in this special culture media and then send it to the lab where they can do a PCR test on it or they can do a culture of it and show those little organisms in there. So we usually like to test the bulls after they've been rested a little bit so they build up the numbers in their prep use. Uh, if we suspect it, we probably need 3 negative tests to make sure the bulls are negative because the test isn't perfect. It doesn't find every animal on every test. If any bull has exposure to cows, we got to test them. If one bull in a bull battery is positive, we might consider simply culling all of the older bulls rather than testing them multiple times, just because it's very difficult to always isolate it perfectly from every animal. Well, we know cows are clean if they're a virgin heifer, if they've never been exposed to a bull, if they've calved successfully, or and they haven't been exposed to bulls at home or only exposed to bulls that have been tested and proven negative. So we want to make sure that when we're developing rules for community pasture that we only let clean cows on as well to prevent this disease. So trick, very common. We still see it, still crops up every now and then. Again, mostly a community pasture disease. And we started calling the community pastures the brothel of the prairies after a while there when we started first seeing this back in the mid 90s. So we got one more to cover here, and then I want to talk about this new disease. Hopefully, we can get through them all. Neospora caninum is this abortion-causing parasite that's one of the most common causes of abortion in cattle in North America. It was first discovered rather late in the late 80s. So, I didn't learn about this disease when I was in vet school. And it was really first described as a cause of abortion in Canadian cattle in 1994, which was, almost 10 years after I graduated. The primary host of this parasite is the canine family. So dogs, coyotes, etc. They're the ones that are the major host of this particular parasite. So dogs or coyotes are the host. They can shed oocysts in their feces, and then if cattle or other ruminants can become infected by eating feed or forage that's contaminated with this infected canine feces. And tends to go and impact the fetus, so infected cows can abort or have stillbirths. They remain infected for life. It seems like they develop some immunity, so yeah, they're still a little more likely to abort, but they don't tend to abort nearly as much as they do when they're first infected. They can also spread the parasite to healthy calves in their uterus occasionally, and so a calf that's born to an infected cow may have an antibody titer shortly after it's born. So it has this complicated life cycle. There's probably some wildlife going on with deer and coyotes and other things like that. The dog or the coyote get infected by eating a carcass or eating a placenta or a aborted calf or something like that. They shed the oocyst, the eggs of this particular neospore in their feces. It contaminates the cattle feed either on pasture or maybe in a grain bin or in a silage pit or something like that. And then it affects the fetus. They get this cross-placental transmission. It can cause birth of a calf that's already infected that looks normal, or it can cause an abortion or premature birth or an impaired calf. Sometimes causes neurological signs in young calves as well. Occasionally, though, it doesn't transmit to the calf, and then the life cycle is broken. But eventually, this animal now, if it grows up as an infected calf, it's a little more likely to abort as an older animal as well. We've looked for this disease and it's pretty widespread. Now we're using serology or looking for antibodies. So almost 7% of the cows in Western Canada, this was in 2018, tested positive for Neospora antibodies. So that means they were infected at some point in their life. They could have been infected as a calf. They could have been infected as yesterday or a few weeks ago as an adult animal. We don't know when they got infected. We just know they've been exposed. And almost two-thirds of the herds had at least one cow test positive for Neospora antibodies. So it's everywhere. It's very common disease. It's important to remember when we're talking about this is the antibodies just mean the cow's been exposed at some time. It doesn't mean that cow's going to abort this year or anything like that. We diagnose it mostly by submitting aborted calves to the diagnostic lab. They usually involve some examination of brain tissue to find this parasite. Blood samples from cows can show evidence of exposure, but that doesn't mean it caused the abortion this time. It might be another cause of abortion. So we sometimes look at blood samples for serology, but doesn't tell us anything because we know it's out there in about 7% of the cows in Western Canada and in two-thirds of the herds. So finding a positive cow doesn't necessarily mean it caused this particular abortion. What's difficult is there's no pharmaceutical or vaccine interventions. We had some vaccines for a little while, but they didn't really work and they've been taken off the market. So we don't have any really effective interventions from that point of view. And there isn't a lot of practical options. Now, thankfully, we don't see a lot of huge abortion storms. If we do see one, it tends to not occur in subsequent years. So if you're unfortunate that you get an abortion storm caused by Neospora, usually the next year it doesn't cause a big problem. We get some immunity, I guess, to some extent. We can try to avoid exposure to canine feces, but that's almost impossible on pasture. Everybody has coyotes around. Most of us have dogs and around, etc., like things like that. Avoiding access to dogs to feed bunks and feed storage maybe is something that they can do in dairy herds and things like that. But again, beef cows on pasture, they're going to get exposed to this. It's pretty impossible to completely prevent that. So, not a lot we can do about that disease. Pretty important cause of abortion, and we do see it regularly in the diagnostic lab. The last thing I want to talk about in the last 5 minutes here is this new disease called thyleria. So that's the parasite. That's the protozoan parasite is called thyleria, but it's spread by a tick. And this tick is the Asian longhorn tick. So this is an article out of Alberta Beef Producers last September, and it's a new emerging disease in North America that's been around for a while in other countries, but we have not seen it here very often. So this Asian longhorn tick, they're the ones that carry this particular protozoan parasite. They're not the problem in terms of the disease, but they're the carrier of this disease. They've been introduced to North America from Eastern Asia. They've spread around the world by moving animals. And they're first identified in New Jersey on cattle. And in 2017, it's now spreading through the eastern states. And there's new cases of this Asian longhorn tick now being identified as far west as Kansas and Oklahoma. And the threat to cattle is not the tick itself as much as it is the disease. And the disease is this protozoan parasite, a microscopic parasite that the tick carries and injects into cattle by feeding on the cattle. And it's called Theileria orientalis ikeda, with a very long name. We'll call it theileriosis. So here's some data out of the last few years out of the US. You can see how it's spread from New Jersey and the East Coast, spreading west, is now identified in places like Kansas and Oklahoma, and Arkansas, etc. So starting to spread across North America. And I guess we're not sure how far it's going to go. It seems to be somewhat adaptable, and whether it'll get up to us or not. Certainly, I think a cow has been identified, an imported cow in Ontario, a dairy cow has been identified with the disease theileriosis, but not with the tick. So we haven't seen the tick here in Canada yet, but we have had cases of the disease in cattle. So it's a single-celled parasite, Theileria. This is the disease carried by this tick that infects the cattle. It's introduced by the tick and it infects the blood cells. So these are red blood cells and white blood cells, and you can see these little dark dots inside them. That's the Theileria organism. It's very small and infects them. It affects those red blood cells and it destroys the red blood cells. So it causes a really severe anemia. And so this is very similar to the disease anaplasmosis, another tick-borne disease that affects cattle, causes anemia, tends to be more of a US disease, although we do see it from time to time in Canada, as those ticks sometimes come up a little farther north than they usually survive. These are different ticks that are carrying anaplasmosis. However, unlike anaplasmosis is a disease of adult cattle. This parasite can actually affect young calves as well as adults. And it causes, these red blood cells are getting destroyed. And so we see these calves get anemia. They get weak and they stumble. They have no energy. They're lethargic. They breathe rapidly. They'll have pale yellow mucous membranes. You can see this picture here of the guy holding up the eyelid and looking at the yellowish mucous membranes on this calf. They might have a bit of fever. Some cows will have late-term abortions. And by the time they're showing these kind of signs of anemia, the disease has progressed significantly. They've been infected for a while. They've had a lot of red blood cells destroyed, and we see clinical disease more common in young calves and in heifers and cows in late gestation and early lactation, and it can kill animals. It has a 5 to 20% mortality rate. It's kind of a little bit dependent on the infection and things like that, but can kill the animal as well. These infected animals now carry the parasite for life in their bloodstream, but it seems to be rare to have a relapse of clinical disease. But other parasites can now transmit that infection to other animals. So sucking lice or things like that we have around Western Canada could certainly transmit the infection to other animals if we had an infected animal present. Once the disease gets established in an area, it seems like the calves are the most likely group to suffer from clinical signs. The cows, maybe get infected in the first year, but then they don't show clinical disease after that. So these longhorn ticks are really prolific and they can produce asexually. So a female can produce eggs that hatch into ticks without having a male around, which is a very unique thing in ticks. They lay huge numbers of eggs. They live in really large concentrations, and they're intermittent feeders, which means they feed on the animal, they drop off in the environment, jump onto another animal and feed again. So they can spread disease very, very quickly. They feed on humans. They tend to intermittently feed and make some really, really great vectors for spreading an infection like theileriosis. And we have no treatment available for theileriosis. We have tick products that we can help to try to control tick populations, but we have no treatment for the protozoa and parasite Theileria. Will it get to Canada? Who knows? It's certainly spreading across the US. It the We'll probably import some animals with theileriosis. Will we get the tick here? Our winters may protect us from endemic populations of the tick because it doesn't love cold weather, although it seems pretty adaptable and so who knows? It may eventually become prominent out here. The good thing is large percentage of infected herds in the US have experienced minimal problems. So despite all the big warnings that we've heard, lots of the herds in places like Virginia and countries like states like that have had problems, they didn't know they were infected until they went in and found it. But the highest mortality seems to occur when the disease is first introduced to a herd. So it's something to be concerned about, something to keep watch for. What are they doing to control it? The current prevention strategies, this tick likes to live in woody pastures and things like that. So they'll burn pastures, try to keep the grass short. They'll do pasture rotations. They'll try to remove that woody encroachment. And then they got to carefully use insecticides because, again, they can develop resistance to the various tick products that we have and can cause problems like that. So, a new disease, it's not here in Canada yet. Hopefully, it stays away, but a very interesting one that you'll probably hear more about in the next few years. So, thank you. I'm happy to try to answer some questions if you have them. And thanks again for having me today.
Perfect. Thank you, Dr. John. Now we will open the floor for Q&A. If you have any questions, feel free to type it in the Q&A section. And if you're someone who doesn't like typing, you can raise your hand and I can allow you to talk. Is there anything else you want to add on, Dr. John, by the time people are typing their questions and all of that?
No, I mean, I didn't talk about anaplasmosis, which is, uh, a very common disease in the US that we sometimes see here in Canada. Another protozoan disease, an important one as well. And as some of those tick populations move north, we may see more
Yeah,
anaplasmosis down the road. But I just didn't have time to cover them all.
perfect. Yeah, let's wait a minute or two. Sometimes takes a
Yeah,
while for people
no
to type
worries.
their questions and by the time if you have something else you can add on, like you can talk about that. Feel free to do that. Perfect. There is a question. For crypto, if a person is bringing in calves to graft onto cows, is there any steps you can take to prevent the disease?
Yeah, don't do that. Uh, there's not a lot of things that you can do. Uh, I guess you could do a fecal sample from that calf to make sure to try to see if it had crypto or not, but um, certainly try to make sure the calf is healthy looking and no problems like that if you do have to bring in calves to graft for disease. But it's a risk. And we can bring in other diseases like salmonella and things like that when we do that. But crypto is a big risk, especially if you're buying dairy calves. It's a much higher rate of infection there. It's probably a little less likely with the beef calf, but the calf that you buy, if you can buy it from your neighbor or somebody like that who you know doesn't have crypto, that would probably be the best solution if you have to do that.
Perfect. Hopefully that answers your question. Is there anything else you want to add on, Dr. John, till then?
No, I think I'm good. I think I've covered the basics at least anyway.
Yeah, perfect. There's another question. Is Protozoal a treatment option for crypto or just Halocure?
Halocure is really the only approved product we have that is is useful for crypto. The trouble with Halocure is you got to give it like for a week. And so you're got to give it every day for a week. So that is difficult to do in a cow-calf situation, especially if you have an outbreak and you have multiple calves infected. You're giving this oral product every day for a week. So that's the challenge with Halocure. Um, and really the only product we have that has any efficacy against crypto. And it really reduces shedding is what it does more than anything else.
Perfect. Hopefully that answers your question. Okay, are there more questions? Is there anything else you want to add on, Dr. John?
No, thanks, Kabir.
Yeah. Okay, we'll wait another minute or two and see if there's more questions. If not, then can end the webinar. Are there any more questions? Is there anyone who doesn't like typing and want me? I can allow them to talk. Okay, till then I can make a quick announcement by the time people are typing their question. So on 30th of June, we have our drone seeding and spreading workshop. If there's someone who has not registered for it and wants to register, there would be a live demo and Marcus will be spreading some silages. If you have not registered and you want to register, you can give me a call to register for that workshop. And I have a low stress handling workshop on 2nd of July. If you are interested in coming for that, feel free to give me a call or you can go to our website to register. Yeah, I guess there's no more questions. Is there anything last ending things you want to add on before I conclude the webinar?
No, I don't think so, Kabir. Thank you for having me.
No? Perfect. Awesome. Yeah. Thank you, Dr. John, for giving us your time today and sharing this valuable insight. Uh, we truly appreciate you coming. And thank you everyone who joined in today. We know you're busy and we really appreciate you taking the time to be here. That brings an end to today's webinar. We hope you found it informative and worthwhile. If you have any feedback or suggestions for future webinars, don't hesitate to reach out to me. We're always looking for new ideas that are useful to producers. Thanks again, and we look forward to seeing you at our next event. Thank you. Have a great day. Yeah, thank you, Dr.